Okay then, so for the linear speed, we just motivated those formulas, and we have an example here. A bicycle has wheels 28 inches in diameter. So remember earlier I gave you a little warning that occasionally you'll be given the information you need, but it won't be the radius, it'll be the diameter. We'll need to do some calculations in order to get that in the correct units. And then the tachometer on the bicycle determines that the wheels are rotating at 180 RPM. So there's kind of, remember, an angular-esque velocity built into this information. We can easily convert that into we have revolutions per minute, and we can convert revolutions, total full revolutions, into degrees or radians. And so once we have RPMs, we can create radians per anything. We can create degrees per any unit of time. We're being asked to figure miles per hour for the actual linear speed. In order to do that, we'll need to find the angular speed. So remember, the formula we're going to use here is the angular speed, and so that angular speed needs to be in radians per unit of time to be used in this formula. So let's start by finding the angular speed first. So the first thing we're going to do is find that angular speed in radians, and since we have it we want to talk about it in hours, let's find it in radians per hour. So we're going to find the angular speed in radians per hour is our goal here. We have 180 revolutions per 1 minute. And I need to convert minutes to hours, and I need to convert revolutions to radians. So my revolutions to radians is going to be 1 revolution. I want revolutions in the denominator to cancel with the revolutions in the numerator, and 2 pi radians. And so now my numerator is in radians as desired. However, I need to get that denominator into hours. So we have 60 minutes and 1 hour are equivalent, which means we're multiplying by 1, but my minutes cancel, and now I have radians in the numerator, and that gets us out. Are we on managing space here? Oh, well, that's, I guess with a zooming, I've got infinite space. So that's equal to 21,600 pi radians per hour. I mean, you got to realize this bicycle wheel is moving really fast, and so it shouldn't be shocking that we're covering a tremendous amount of radians over a long period of time, relative an hour. Now, so we have our angular speed up here. We have the omega now, and we can plug that in. However, we need the radius, and we don't have the radius. We have the diameter, so we need to do a quick conversion here of converting the diameter to the radius, and so I'll just put finding radius. And the radius is equal to 1/2 the diameter, and that's equal to 1/2 28 inches, which is going to be 14 inches. You could also just, I don't know, 28 divided by 2, 14. If you did that on your head, you would just want to make a little statement here as saying diameter is 28 inches, so radius is 14 inches. And I think that your reader could follow along with your thinking there on how you got that. All right, so we now have the radius, right? And we now have the angular speed. The only problem is that we've got the radius in inches, and we've got the angular speed in radians per hour. So when we do that math, we're going to get inches per hour, and we want miles per hour. So we're going to have to do some conversions there on that. So the third thing we're going to do is we're going to find the linear speed And so that linear speed is going to be equal to the radius times the angular speed. And so that's going to be our 14 inches times our 21,600 pi radians per hour. Now the units on this right here are in inches per hour, right? We have inches in the numerator. Radians go away from a unit perspective, and then we have hours in the denominator, and that's not what we want. So we're going to need to do some conversion on that. So that is 302,400 pi, and that's going to be in inches per 1 hour. And we're going to want to convert that. So let's see, we need inches in the denominator, so 12 inches is 1 foot. And now our inches cancel, and we're in feet per hour, but we don't want to be in feet per hour. So 5,280 feet is 1 mile. And our unit conversion there, when we do all of that math, gets us out, well, we can just go with a decimal here, about 15 miles per hour.